Today we are here to talk about the chemistry behind whitening toothpaste. Let's go over some background information. All toothpaste has two functions: cosmetic, which is improving the teeth's appearance by removing stains from the surface, and there is hygienic, which is to prevent tooth decay by removing food particles and plaque from teeth. Whitening toothpaste is just designed to work even harder on removing stains from your teeth while doing everything that regular toothpaste does. Before we go over how whitening toothpaste removes stains, let me explain how stains come about. Each of your teeth is made up of an inner dentin layer and a hard outer enamel layer, which protects the teeth. As you consume the majority of food and drinks, another layer gradually forms on top of the enamel layer. Basically, the foreign material accumulates to form a pellicle film over the enamel layer. The problem is, as this pellicle layer sits on your teeth for years and years, the foreign material gets into the enamel. The enamel layer is made up of hydroxyapatite crystals, which form microscopic hexagonal rods. Staining agents can work their way down into the tooth where you simply can't scour them away because this enamel is porous. The deeper the stains are is basically harmless, but many people find them very unattractive. This is where the chemistry of whitening toothpaste comes in. The whiteners use bleaching chemicals to get down into the tooth enamel and set off a chemical reaction. More specifically, an oxidation reaction that breaks apart the staining compounds. This bleaching chemical is a chemical agent known as carbamide peroxide. When used on the teeth, carbamide peroxide breaks down into hydrogen peroxide, H2O2, and urea, with hydrogen peroxide being the main whitening ingredient. This chemical reaction is the hydrogen peroxide and urea working their way into the porous parts of the enamel to discolor and then break apart stain deposits in the dentin. To remove surface stains, whitening toothpaste may also include abrasives to gently polish the teeth, like in this picture I am drawing now. They remove any substances on the enamel and create a smooth, shiny surface for the teeth. Examples would include substances such as calcium carbonate or even silica. Here is the molecular structure of calcium carbonate. Enough molecules like this one creates a salt-like substance that is strong enough to smoothen and polish the enamel. Abrasives also slow the growth of hard deposits of mineralized plaque. Also, abrasives break down the stain matrix. It does this by removing calcium bridges between the stain molecules and surface proteins on the teeth, making the stain easier to remove. These mild abrasives contribute a lot to how whitening toothpaste works. Also, whitening toothpaste contain additives such as sodium tripolyphosphate to break down or dissolve stains. Here is the molecular structure of sodium tripolyphosphate. These additives act like a detergent to help clean teeth by also dissolving stains. This further contributes to the chemistry of whitening toothpaste. However, the whitening process can permanently reduce the strength of one's teeth because the process scrapes away a protective outer layer of enamel. They must be abrasive enough to do this without damaging the enamel or any exposed dentine. This image compares the exposed dentine to a cracked eggshell. And that is all for the chemistry behind whitening toothpaste. Thank you for watching.